In this presentation, we will discuss the electromagnetic spectrum. The electromagnetic spectrum consists of waves of varying wavelengths and frequencies. These include radio waves, microwaves, infrared light, visible light, ultraviolet light, X-rays, and gamma rays. The relation between frequency, wavelength, and energy is seen in this depiction of the electromagnetic spectrum. For all waves, the speed of propagation is equal to the frequency times the wavelength. Because all electromagnetic waves travel at the same speed, the speed of light, the product of their frequency and wavelength is constant. This means that the greater the frequency, the smaller the wavelength, and vice versa. Electromagnetic waves can transfer energy to a system through their electric and magnetic fields because these fields exert forces and move charges. The energy of a photon, which is a discrete packet of electromagnetic radiation, increases with increasing frequency and decreasing wavelength. The properties and applications of electromagnetic waves are dependent upon their unique frequency, wavelength, and energy. Different materials can transmit, reflect, or absorb different types of electromagnetic waves. For example, glass is transparent to or transmits visible light, but is opaque or reflects shortwave UV radiation as depicted in this image. First, radio waves. These are the lowest frequency electromagnetic waves. Radio waves are produced by currents in wires and circuits and by astronomical phenomena. Some of the lowest frequency radio waves come from AC power lines at frequencies of 50 to 60 Hz. Extremely low frequency or ELF radio waves of about 1 kHz are used to communicate with submerged submarines. The longer the wavelength, the further they are able to penetrate in the water. Everyday items like car keys, remote controls, and cell phones, as well as televisions that use roof antennas, use radio waves as well. How do radio waves carry information that can be decoded into sound? Sound signals encoded as audio waves are added to a specified carrier wave to create either an amplitude-modulated AM or frequency-modulated FM wave. When this modulated wave reaches a receiver tuned to the carrier wave frequency, the carrier wave is taken away to leave the audio signal that is used to produce sounds heard over a speaker. AM radio waves range from 540 to 1600 kHz. FM radio waves have a varying frequency between 88 to 108 MHz. FM radio signals are usually clearer because amplitudes of different waves can add, while an FM radio receiver can reject amplitudes other than that of the basic carrier wave. Microwaves are the highest frequency electromagnetic waves that can be produced by currents in macroscopic circuits and devices. They can also be produced by thermal agitation of atoms and molecules. Microwaves have frequencies ranging from 109 to 1012 Hz. Microwaves are used in satellite transmissions, in radar, and of course in the household microwaves used to heat food. Microwave ovens work as accelerating electrons produce microwaves at a frequency of 2.45 GHz, which induce an alternating electric field. Because water is polar, the water molecules move, trying to orient themselves with the electric field. The rotation of the water molecules causes thermal agitation, which heats the food on the inside and the out. Infrared radiation has too high of a frequency to be produced by electrons in a circuit. Instead, it is generally produced by thermal motion and the vibration and rotation of atoms and molecules. Frequencies of infrared light extend up to the lower limit of visible light, that is, below red light, giving these waves their name that means below red. About half of the solar energy that comes to the Earth is in the infrared region. These waves are absorbed in the atmosphere and radiate back to the Earth. This, along with the infrared radiation emitted by the Earth, keep Earth's temperature relatively constant. Unlike humans, some animals such as mosquitoes, vampire bats, and bed bugs can detect some portion of the infrared spectrum. Infrared is emitted by warm objects as the movement of its atoms increases with increasing temperature. Infrared radiation can be interpreted by night vision scopes and infrared cameras, which are then converted into an electronic signal to produce a visual image, as the one seen here. Visible light is the only portion of the electromagnetic spectrum that the human eye can detect. It includes wavelengths between about 400 to 750 nanometers. Visible light is produced by vibrations and rotations of atoms and molecules, as well as by electronic transitions within atoms and molecules. Radiation from the sun peaks in the visible spectrum. These electromagnetic waves are absorbed by the Earth and re-radiated at longer wavelengths in the infrared region, which contributes to heating the Earth. Colors are associated with certain wavelengths in the visible light spectrum. Red light has the lowest frequencies and longest wavelengths, while violet has the highest frequencies and shortest wavelengths, with orange, yellow, green, and blue in between them. White light contains all the colors in the visible light spectrum. When white light hits an object, the object absorbs most of the wavelengths of light, and the color it reflects is the color the object appears. Some colors, such as pink and brown, are not in the visible light spectrum themselves, but are the result of a mix of multiple wavelengths. Ultraviolet means above violet, with wavelengths extending from violet light at 400 nanometers down to waves with wavelengths of 10 nanometers. Solar radiation is divided into UVA, UVB, and UVC radiation, with UVC having the greatest frequency and the highest energy. Much of the high-energy UVC light is filtered out by ozone in the atmosphere. UVB and UVA light not filtered out by ozone can be absorbed by melanin in the skin. Prolonged exposure causes sunburns, and over-repeated exposure can cause skin cancer, as these high-energy waves can cleave bonds and form radicals. Sunscreen has compounds that are able to absorb different regions of the UV spectrum to protect skin. However, not all UV radiation is bad. A certain amount is needed to produce vitamin D in the skin to maintain bone health. Dangerous levels of UV radiation are kept from reaching the Earth by the ozone layer. Unfortunately, ozone concentrations are depleting due to a breakdown of chlorofluorocarbons, or CFCs, by UV radiation. Ozone depletion is greatest over polar regions like Antarctica. X-rays have wavelengths in the range of 0.01 to 10 nanometers. They have enough energy to ionize atoms and disrupt molecular bonds, which makes them harmful to living tissue and can cause radiation sickness and increased risk of cancer. However, this slight increase in health risk is outweighed by the benefits of X-ray imaging in medical examinations. X-rays are used in X-ray crystallography to help determine the crystal structure of molecules and compounds, CT scans, airport security imaging, and in some cancer treatments. How do imaging X-ray machines work? X-rays are mostly transparent too, meaning they can pass through body tissue like skin and organs, but bones, which have a greater density, absorb most of the high-energy X-rays. A X-ray detector is placed opposite the body area to be imaged. X-rays that pass through the tissue hit the detector and are shown in shades of gray, while areas where X-rays are absorbed, like in bones, appear white. Gamma rays have the highest frequency of electromagnetic waves. They are produced by an electromagnetic radiation emitted by a nucleus. X-rays and gamma rays are distinguished somewhat arbitrarily. In the past, wavelengths smaller than the arbitrary value of 10 to the negative 11th meters were considered gamma rays. Now they are distinguished by their source. X-rays are emitted by electrons, while gamma rays are emitted by the nucleus, often due to radioactive decay of atoms. Gamma rays are penetrating ionizing radiation, so it can cause damage throughout the body, including radiation sickness, DNA damage, cell death, and increased incidence of cancer. To review, the electromagnetic spectrum consists of varying ranges of wavelengths and frequencies, from radio waves to gamma rays. These waves have important applications in our daily lives, from communication devices to vision and to medical and scientific applications.